Dear students, now you have understood what is the luminosity or absolute luminosity. Now we are going to understand one more concept, that is apparent magnitude. That is apparent magnitude. What is meant by apparent magnitude? Okay. When you look at the stars in the sky during the night, you don't see all the stars equally bright. Some are very, very shiny, bright, and some are very, very dim. Depending on the star's brightness, about 2 centuries before the Christ, okay, so a person called Hipparchus, his name is what? Hipparchus, probably Greek philosopher, the Hipparchus. Okay, so he classified the stars. He classified about 1,000 stars, okay, into different categories. So while naming the category, he called them as, he made 6 groups of the stars depending upon their brightness. So he called them as first order stars, second order stars, third order stars, like that, sixth order stars. So according to his classification, first order star is the brightest star on the earth, and then second order star is a little dimmer than that, third little dimmer, sixth little dimmer. This is the first effort to classify the star according to brightness. Why we call it as apparent? Because they look that much brightness, not because they are different, means they are having different luminosity. Of course, they may be having different luminosities, though the 2 stars having the same luminosity. If one star is nearer to Earth and another star is away from the Earth compared to that first star, then the first star will appear more bright than the star which is farther than that star. That means the brightness on Earth depends upon their distance, though they may be having same luminosity. Means the brightness does not depend on how much radiation that star is emitting. Of course that depends, but it also depends on the distance, how much it is from the Earth. If the star is farther from the Earth, then its brightness will be reduced. Just like if 2 persons, taller and shorter persons, are standing at equal distance from us, so you can find out the difference. Suppose a taller person is standing little away from us than the shorter person, then both of them may look equally height. If taller person is made to stand too farther, then size of the shorter person may be larger than the size of the taller person. So the relative distance also counts. Same way the brightness of the stars also. Hipparchus just observed the brightness as they look from the Earth, and he classified it. Therefore, he called them as apparent magnitudes. Okay. So next comes in 18th century a person called Pogson. The name of the scientist is Pogson, in 1856. Okay. So what did he do is, Pogson, he assumed that the first order star and sixth order star, okay, order star, in terms of brightness, the ratio is 100. Means, suppose you take the luminosity of the first order star is L1, the second order star is L6. Okay, and the ratio of brightness between first order star and the last order, that is sixth order star, he considered it as 100. And one more assumption he did was every next order star is having the same proportion of brightness with its previous star. That means the ratio of brightnesses of first order star to the second order star is equal to ratio of second order star brightness to the third order star is equal to ratio of third order star to the ratio to the brightness of fourth order star. This is again equal to fourth order star to the third order star. Sorry, 1 2 2 3 3 4 4 5 and 5 6. So that means every order star divided by its next order star has got a same ratio. We don't know what is this ratio. Let us call this ratio as X. Okay. Now if you multiply all this, what you will get? L1 by L2 into L2 by L3 into L3 by L4 into L4 by L5 into L5 by L6 is equal to, so all are equal to x. So this is equal to x to the power 5 because x into x into x into x into x to power 5. Now L2 L2 L3 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 L4 L4 L5 L5 cancels. What remains is L1 by L6 is equal to x to power 5. What he assumed? It is equal to 100. Got the point? So this implies that x is equal to 1/5 root of 100. If you calculate 1/5 root of 100, you will get the value 2.512. Okay, you get 2.512. Therefore, the brightness of two stars whose apparent magnitudes differ by 1 unity, means the second order to first order, third order to second order, so differs by a magnitude of or brightness by 2.512 factor. Okay, x is equal to 2.512. Okay, so now suppose you take the brightness of the star which is having mth star. So m may be between 1 and 6. So luminosity it is. Luminosity of it may be first star or second order star or third order star, whatever order star. If you take the luminosity of any other order star, Ln, m and n represent order of that stars. This can be written as 2.512 to the power n minus m. Got the point? So this is Lm divided by Ln will give you 2.512 to the power n minus m, where m and n are the orders of the star. Now let us call this as equation 1. Okay. Now if you calculate or if you take log on both sides, what you'll get? Log of Lm divided by Ln is equal to mn minus m into log of into log of 2.512. If you simplify this, you will get log of Lm divided by Ln is equal to log of 2.512 is equal to 0.4 into n minus m. So this implies n minus m is equal to, if you take 0.4 this side, it will become 1 upon 0.4. The value of 1 upon 0.4 is 2.5. So 2.5 into log of Lm divided by Ln. Okay, call this as equation 2. So this is an important relationship between order of the star and their relative brightnesses, Lm and Ln. Suppose you know the relative brightnesses, then you will get, or you know one of the order of the stars, you can calculate the order of the other star. Okay, so this is very, very important equation. So here we consider that n is greater than m. If m is greater than n, it will be reverse. Okay, so in the next video we can understand what is absolute magnitude. All right, thank you.